What's going on, guys? We are going to make an explosion particle effect using just JavaScript. Let's go. What's going on, guys? Another day, another video. You know, it's actually been quite some time since I made my last video. I've been fairly busy kind of juggling multiple things, but most importantly, I've been working on my skill set as an overall developer. So hopefully that will translate into better videos for you guys. So if you do any type of web development, most likely JavaScript will be a component in your pipeline. At this point, it's pretty much an understood necessity. Having said that, we're going to use JavaScript in a slightly different fashion, and hopefully it'll be a little bit more fun. We're going to create an explosion or burst type of particle effect. If you've played any video games or done any type of game development, I'm pretty sure you know what particle effects are. But if you haven't, here's some examples. Now, full disclaimer, the effect we create will not be as extravagant compared to what you just saw. We're actually going to make our particle effect using simple circles. However, I feel that this foundation knowledge will help you to easily understand how particle effects work. Now, in order to create this effect, we'll need to touch on a few different concepts. For example, we'll touch on some basic trigonometric functions, and that may sound intimidating, but it's actually not that bad. We'll also touch on concepts such as vectors, velocity, and gravity. And remember, it's all vanilla JavaScript. So let's get started. Just as an FYI, I'm using Sublime Text as my editor, but you're free to use whatever editor you want.
Okay, so let's get started. I'm going to write some code, and then I will explain what I'm doing afterwards. Our particle will be represented as a circle. We use the HTML canvas to render that circle. As an FYI, a canvas tag is used to draw graphics. You can think of it as a container, and we use JavaScript to draw the graphics inside of it. GetContext is a built-in HTML object that handles the drawing. The arc method takes an X and Y value that represents the center of the circle, followed by the radius of the circle. The last two parameters are the starting and end angle. The top left corner of a web browser has the position of 0, 0. We're going to position the center of our circle at the center of the screen. Radius is a line segment that starts from the center of a circle to a given length. The arc method calculates the starting and end angle in radians. A radian is a unit of measure based on the radius of a circle. Since the arc method expects the angle in radians, we'll need to convert the angle we want into its radian equivalent. 1 radian is roughly equal to 57.3 degrees. A half circle is 180 degrees. 180 degrees in radians is roughly 3.14, which happens to represent the mathematical constant pi. 2 pi is equal to 6.28 radians, which represents 360 degrees, a full circle. That said, we have a starting angle of 0, and we want our end angle to be a full 360 degrees represented in radians. So we have a circle. Next, we need to discuss how we'll animate our circle. We'll need to understand a good approach to setting our circle's position. This is where vectors come into play. A vector is typically presented as an arrow. It's made up of magnitude and direction. The length of this line shows the vector's magnitude, and the arrowhead represents the direction. The direction is the angle the arrow is pointing. A simple way to represent a vector is using X and Y coordinates. X being the vector's horizontal component, and Y being the vector's vertical component. We can use vectors to represent multiple things. Take velocity, for example. Velocity is essentially speed combined with direction. A vector's magnitude gives us velocity speed, and the vector's angle gives us velocity direction. The longer the magnitude, the greater the velocity speed. We can also add vectors together. A single vector can be represented as the sum of 2 vectors. What do I mean by that? Say that we have vector h. I can say that vector h will be the sum of the red and blue vector. Expressing vector h as the sum of the red and blue vectors breaks it down into its vertical and horizontal components. Let's say that vector h has a length of 8, and its direction is 30 degrees. The direction is basically the angle in between where the arrow is pointing and the positive x-axis. Using the direction and magnitude, or length, we can figure out the magnitude of the vector's horizontal and vertical components. If you look closely, this figure represents a right triangle. We actually have the length of the hypotenuse. Now, thinking back to your days of geometry, or if you were brighter than me, trigonometry. The hypotenuse is the longest side of a right triangle. The side directly across from the angle is called the opposite. Lastly, the side directly next to the angle is called the adjacent. That said, we can use standard trigonometry to figure out the vertical or opposite and horizontal or adjacent components. To figure out the opposite, we can use the sine function. We can say that the sine of angle A is equal to the opposite over the hypotenuse. At that point, we just need to use some basic math. We first calculate the sine of the angle, and then we want to solve for the opposite. So we multiply both sides by 8. We can use the cosine function to figure out the adjacent length. We can say that the cosine of angle A is equal to the adjacent over the hypotenuse. That gives us a vertical component length of 4 and a horizontal component length of 6.92. So what gives? Why are these even useful? Well, if we make vector h the velocity of our circle, we then know that our circle will move 6.92 units to the right on the x-axis and 4 units up on the y-axis. Now that we understand velocity, we're going to create a vector class where we'll implement a few functions. So, we've given our vector two properties of x and y. We've added methods that do the following: return x and y, increment x and y by another vector, and decrement x and y by another vector. These should be pretty straightforward. Now again, a vector is a combination of magnitude and direction, or you can say length and an angle. Let's start creating a method to set the length and a method to set the angle. I'll create a function declaration that will eventually return the real angle. We'll take the cosine of our angle and use that to calculate the horizontal component, while the sine function will be used to calculate the vertical component. So now we'll go back and write a method to get our angle. So what do we have available to us? Well, we have the x and y, which is our horizontal and vertical components. X and y correspond to the adjacent and opposite sides of the right triangle, which means we'll use the tangent function. To get the angle, we'll need to use the inverse of the tangent function, which is called arctangent, or atan2. Now, I hope you're still with me because I know this is a lot, but I think we're making good progress. We've just set the length or magnitude of our vector. If you remember, velocity is speed plus direction. So now we'll set our direction, which is going to be our angle. In order to set our angle, we'll need to utilize the vector's length. Let's assume that we have our length already. At this point, it becomes really simple. We can use the same logic from our set length method. Now we write a method that returns the length. If we know the horizontal and vertical components, x and y, or the adjacent and opposite, we can calculate the magnitude of the hypotenuse using the Pythagorean theorem. The theorem basically takes the square root of x squared plus y squared. That will give us the length of our vector. We now have what we need to give our circle velocity, so let's configure our circle. We'll also need to add a function that constantly updates our position based on our velocity. We'll update our circle constructor, pass in a random speed between 2 and 5. Also, we'll set the direction of 45 degrees. Let's give it a shot. And that looks good to me. Now we've got our circle moving in a given direction. We now want to give it some dynamics to make the movement feel more like an explosion or a burst. First way we can accomplish this is to apply acceleration to our velocity. Acceleration has to do with how fast velocity changes, and it also has a direction. It's the change in velocity over time, and it's typically represented as meters per second squared. So let's say you're on your bike and you're going 5 meters per second. Then you pick up speed, and within the next 3 seconds, you're going 14 meters per second. Your velocity is now increased by 9 meters per second over a period of 3 seconds. As a result, your speed changes by 3 meters per second. I hope that made sense. As I said before, acceleration takes direction into account as well. Let's say that you're cycling 12 meters per second going left, and within 8 seconds, you're cycling 12 meters per second going right. From 12 meters per second going left to 12 meters per second going right, this results in an acceleration of 3 meters per second. Now, gravity is a type of acceleration. Gravity will accelerate any object at a rate of 32 feet per second per second. What that means is if an object falls for 1 second, it will reach a speed of 32 feet per second. After 2 seconds, it will reach a speed of 64 feet per second. Adding acceleration and gravity will allow our circle animation to look more realistic. So let's plot this out. For illustration purposes, let's say our circle starts here and the position is 0, 50. Our starting velocity will be 0, -3. We will also apply an acceleration or gravity of 1, 2 to the velocity every frame. So on the first frame, our circle is at 0, 50. The velocity of 0, -3 moves the circle up 3 units. Acceleration is then applied to the velocity, and the velocity is updated to 1, -1. On the next frame, velocity moves the circle to 146. Velocity is then updated to 2, 1. On the next frame, velocity moves our circle to 347. Velocity is then updated to 3, 3. Velocity then moves the circle to 650, and this pattern continues. The process of adding acceleration to velocity and velocity updating the position is called the Euler method. We have exactly what we need to create our explosion. So let's go ahead and build that out. We'll create a new acceleration vector called gravity. The x value will be 0, and we'll use 0.1 as the y value. Now, 0.1 is small, but our animation will be running every frame, so the adjustment of the velocity should be seen pretty quickly. 0.1 on the y-axis will make the circle go down. Next, we just need to update our move method and add the gravity to the velocity. We'll update our circle constructor to receive a gravity parameter. We'll increase the randomness of the speed, and we'll make the direction random instead of hard coding 45 degrees. We'll also decrease the size of our circle. If you notice, gravity literally pulls the circle down, but I promised an explosion, so it needs to look like an explosion. And we'll accomplish that by essentially adding more circles. So let's give it a try. We got our explosion. I think that it looks pretty good. So really quick, let's add some color to each circle to make it look a little bit cooler. So colorful explosion.
I'd say that's looking pretty good. Great job, guys. If you don't mind, leave a few comments and let me know some other cool things that you've done with JavaScript. I appreciate you guys for stopping by. I hope that you learned at least one new thing. Please continue to like, subscribe, comment, hit that notification bell icon, all that jazz, and I will see you on next time.